Hello students, this is Dr. Nimalangshu here. So till my previous class we have seen how we can determine the order of reaction. We have done one example also to see how the order of reaction is determined. Okay, and also we can I can say that there are many methods to determine the order of reaction. Okay, so one by one we will solve that method. So before going into the details, I want to tell you one important question of your NCERT or final exam, that is from rate constant also we can determine the order of reaction. Okay, so the question may come like this. In one mark question it may come like this: identify the order of reaction, identify the order of reaction from the following rate constants, from the following rate constants. Okay, this is the question. So rate constants have been given to us. So from rate constants we have to determine the order of reaction. So number one is k equal to 2.3 into 10 to the power minus 3 liter per mole per second. Okay, second one I should write it here also. You can write. So this is a very important question. You can put so many stars as you like. Okay, so far as your final exam is concerned, this is very important. This question, this type of question is very important. So the next question is k equal to 1.25 into 10 to the power minus 2 per second, only per second. Okay, the third question is k equal to 2.94 into 10 to the power minus 6 mole per liter per second, So the rate constant values are given. From the value of rate constant we have to determine the order of reaction. Means what we have to determine? We have to determine the small n. Okay, now see the formula for rate constant is. So how will you solve this equation? This is a one mark question, so no need to pass so many time in finding the order of reaction from the value of so many rate constants. Okay, so this is a one mark question, so we have to do as fast as possible, and these type of questions are also important in your entrance exam point also. So this we know that the value of rate constant is, we know that the k is equal to mole to the power 1 minus n mole to the power n minus 1 liter to the power mole to the power n minus 1 liter mole to the power 1 minus n mole to the power 1 minus n liter to the power n minus 1 per second. So this is the unit of, or this is the value or formula, I can say, formula of the rate constant, whatever we have done in our previous class. Okay, so now from this we can find the order of reaction. So which value coincides? If we put we will put what value of n, so that we will get k equal to this value. So for question number 1, what value of n can be put to get k equal to 2.3 into 10 to the power minus 3 liter per mole per second. So what value we will put? So for this we can see that if we put n equal to 2, now go on putting. If we put n equal to 0, then k comes as mole per liter per second. Okay, if we put n equal to 1, then k comes as per second only. And if we put n equal to 2, then our k is equal to mole liter to the power liter into mole to the power minus 1 per second, liter per mole per second. So this is coinciding with this value. This is coinciding with this value, means that n is equal to, for this value of rate constant, n is equal to 2. For this value of rate constant, n is equal to 2. Okay, so that is why you can say that it is a it is a second order reaction. It is a second order reaction. Okay. So from value of rate constant, because we have the formula of rate constant, that is k is equal to mole to the power 1 minus n liter to the power n minus 1 per second. So go on putting the values of n. If we first put n equal to 0, then k comes out to be mole per liter per second. If we put n equal to 1, then k comes out to be only per second. And if we put n equal to 2, then k comes out to be liter per mole per second, which is coinciding with this value. So it means that the first equation or the first question is an example of second order reaction. So similarly, we can solve the second one also and third one also. So how we will solve? Let's see. So the second one, it is given, the value of k is given. The second one, the value of k is given. K is equal to 1.25 into 10 to the power minus 2 per second only. So don't bother about the value of this numerical value of k. You just concentrate on the units. From the units we can find from the value of units of rate constant, we can find the order of reaction. So now let's go on putting this value. If n equal to 0, then k comes out to be mole per liter per second. If n equal to 1, then k comes out to be only per second. Okay, which is coinciding with this value. So means that the second question is an example of first order reaction. Second question is an example of first order reaction. Similarly, for third question also, for third question the value of k is given 2.94 into 10 to the power minus 6 mole per liter per second. Mole per liter per second. Okay. So if we now go on putting here in this formula, go on putting the value of n is as 0. अगर n 0 मतलब हम लोग बिठाते हैं तो क्या आता है, k is equal to mole per liter per second. So means that this is coinciding with this value. This is coinciding that n is equal to 0. That is, it is a zero order reaction. It is a zero order reaction. So in this way, one more question comes in your final exam, and also in your entrance exam also you will be given some options, and you will be given that identify the order of reaction from the following rate constant. One value they can give, and in the option you will be said zero order reaction, first order reaction, second order reaction, and none of the above. Which one is correct answer? Just go on putting the value of n, that is n equal to 0 first, then n equal to 1, then n equal to 2, like this, then n equal to 3. Okay, so like this go on putting whatever value will coincide with your given value, that will determine the order of reaction. Okay, so ऐसा क्वेश्चन आ सकता है. ठीक है. Now this order of reaction कल हमने एक एग्जाम्पल किया था. So order of reaction determine कैसे मतलब कल एक एग्जाम्पल किया था कैसे from rate and concentration we have found the order of reaction. So there are various methods to determine the order of reaction. So there are various or different methods to determine the value of rate constant the value of order of a reaction. So now the next point of our discussion is determination of order of reaction. Determination of order of reaction. So in this we can say that order can be determination of order of reaction. So in this you can say that order can be determined in many ways. Order can be determined in many ways even from the value of rate constant also we can determine the order of reaction. Even from the value of the units of rate constant. But precisely I can say that from the value of the units of rate constant we can determine the order of reaction. Okay. So now there are various methods to determine the order of reaction. So the first method is said to be a graphical method. Graphical method. So which is nevertheless of very importance to us. So the second method is initial rate method. Initial rate method. Okay. The third method is Oswald dilution method. Oswald method. Okay. Oswald method. And the fourth one is integrated rate law method. Integrated rate law method. Okay. Integrated rate law method. And the fifth, last but not the least, the fifth one is half-life method. Half-life method. So देखो कल मतलब प्रीवियस क्लास में जैसे हमने ऑर्डर डिटरमाइन किया था, किससे डिटरमाइन किया था? We have been supplied with the concentration of reactants and also with the rate of the reaction. So from the rate also we can find the order of reaction. So this method ये हमने कल हमारे क्लास में कर चुके हैं, ठीक है? So ये this method is done with us. So now we are left with other methods. Of these 5 methods, this method is not of importance. This method is not of importance. These two methods and this method is a very important method. These two methods, integrated rate law method and half-life method and initial rate law method. Okay, initial rate method. Okay. Now, which we have done already in our previous class. Today also we have seen one example also. So initial rate method we have finished with. We are done with this method. So another method is that which we want to mention, which I want to mention over here. It is a Van't Hoff differential method. Van't Hoff. The sixth one is Van't Hoff differential method. So from this method is also of importance so far as your entrance point is concerned. So my dear students, please look at this method. What I am going to explain it over here. So this method is of very importance so far as your entrance point is concerned. Sometimes in the board exam also this method is being asked. Okay. So this now let's see what is Van't Hoff differential method. Let's see what this method is and how using this method we determine the order of reaction. Okay. So let's see that method. See, we know that rate of reaction. We know that very well that rate of reaction varies as the nth power of concentration of reactant. Rate of reaction varies as the nth power of concentration of reactant. Suppose we have one reaction where reactant is C1 and the stoichiometric coefficient of this C1 is N. So and it gives rise to product. So we know that rate of reaction, that is minus dC1 by dt minus dC1 by dt is equal to K into C1 to the power N. Okay. So because we know that rate of reaction varies as the nth power of concentration of reactant. Rate of reaction varies as the nth power of concentration of reactant. So you might be delighted over here, my dear students, because in our previous classes I have put the concentration as the molar concentration. That is, we have put the concentration in third bracket. So why I have not put over here? You can omit, you can put third bracket also, and also you can omit also. Okay. So for my convenience, for the sake of my convenience, or for the sake of my simplicity, I have not given this third bracket. Okay. But the fact is that the rate of reaction varies as the nth power of the concentration of reactant. Okay. So this, let's put this one as equation 1. Suppose we have got another reaction, that is NC2 arrow, it is giving rise to product. So for this one, minus dC2 by dt is equal to Kc2 to the power n. This is equation 2. Okay. Now we will take logarithm of both these equations. Okay, we will take logarithm of both these equations. So taking logarithm, what we will get? Taking log, what we will get? Minus log of minus dc1 by dt, log of minus dc1 by dt is equal to log of k. Log ab, we know that log of k c1 to the power n. Okay, so we know that log ab is equal to log a plus log b. Log ab is equal to log a plus log b. So from this concept, we can write it over here as log of k plus, and again another thing, log of 2 to the power x is equal to x log 2. So these two concepts of mathematics is going to use over here. So log of c1 to the power n is equal to n log of c1, n log of c1. Okay, so this is the one equation. So if we take log of the second equation, what we will get? Log of minus dc2 by dt is equal to log k plus n log c2, n log c2. So these two equations we got. So first one is log of minus dc1 by dt is equal to log k plus n log c1, and the second one is log of minus dc2 by dt is equal to log k plus n log c2. Now if we subtract equation, let's put this one as equation 3 and let's put this one as equation 4. If we subtract equation 4 from equation 3, what we will get? So subtracting equation 4 from equation 3, what we will get? Okay, let's see what we get. So subtracting equation 4, so equation 4 minus equation 3, what we will get? Log of minus dc2, sorry, I made one mistake. Equation 3 minus equation 4. Equation 3 minus equation 4. So log of minus dc1 by dt minus log of minus dc2 by dt is equal to log of minus dc1 by dt minus log of minus dc2 by dt is equal to log k plus n log c1 minus log k plus n log s, not plus, it will be minus n log c2. So this log k cancels out. So what we will get? Log of minus dc1 by dt minus log of minus dc2 by dt is equal to, that is n log n common, then if we take log also common, n log c2 minus log of c1, log c2 minus log of c1, this one c1 minus, so sorry, log c1 minus log c2, log c1 minus log c2. Okay, log c1 minus log c2. Now we from this what we will get? N is equal to log of minus dc1 by dt minus dc1 by dt minus log of minus dc2 by dt divided by log of c1 minus log of c2. So using differential form of the reactant and also the concentration of reactant, we can determine the order of reaction, that is n. So this is another method which is named as Van't Hoff differential method. So this is very important so far as your entrance point is concerned, especially so far as your entrance point is concerned. Now we will move to another method which is called integrated rate law method. Integrated rate law method. So let's see what this method is. Integrated rate law method. Okay. Now see, we know that there are reactions of various orders. So next one is integrated rate law method. Integrated rate law method. So there are reactions of various orders, like we have zero order reaction, we have first order reaction, we have second order reaction, we have third order reaction, so and so on. So let's start with zero order reaction. The first one we are going to start is zero order reaction. Zero order reaction. Okay. So this is one. Now what is zero order reaction? What is zero order reaction? The zero order reaction are the reactions in which rate of reaction is independent of the concentration of reactant. This rate of reaction is independent of the initial concentration of reactants. Okay. So this type of reactions are called zero order reaction, because we know that if we have an equation that is A to P, so what will be our rate equation? K R equal to K concentration of A to the power 0. Okay, means is equal to K, means concentration or term of concentration of K is not used here in our final rate equation. Means that rate of reaction is independent of the initial concentration of reactant. So this is an example of this type of reactions are said to be zero order reaction. Okay. Now these zero order reactions are relatively they are uncommon. Zero order reactions are relatively uncommon and they occur under special conditions. They occur under जैसे कि लास्ट क्लास में हमने देख लिया है कि ammonia decomposition on platinum surface. Okay, so it is a special type of reaction. So zero order reactions are little bit or relatively you can say uncommon reactions, and they occur under special conditions. Okay, some enzyme catalyzed reactions are also zero order reactions. Some enzyme catalyzed reactions means the reaction which is occurring by enzyme catalysis, that is those reactions are example of zero order reaction. So let's see some examples of zero order reaction. So examples we can see. Examples, one example we have seen in our last class, that is another example is number 1, H2 in gaseous state reacts with Cl2 in gaseous state under sunlight or EV H nu will give us HCl, twice HCl in gaseous state. Another reaction we have seen in our last class, that is twice NH3G, and it occurs at 1130 Kelvin and high pressure and presence of platinum catalyst. It breaks to give nitrogen in gaseous state and hydrogen also in gaseous state. Okay. The third example which I am going to cite over here is reaction between acetone and bromine. Reaction between acetone and bromine. Okay. Reaction between acetone and bromine. Okay. This is also an example of zero order reaction. This enzyme catalyzed fourth one is enzyme catalyzed reactions. Enzyme catalyzed reaction. These reactions are generally of zero order reactions. Okay. The fifth one is when the reaction uses some catalyst, that is some metal surface is used as catalyst. Those reactions are said to be of zero order reaction. That is absorption of gases on metal surface. Absorption of gases on metal surface. Absorption of gases on metal surface, like this one. इसमें क्या होता है, इसमें क्या हो रहा है कि जैसे लास्ट क्लास में हमने देख लिया है कि इसमें प्लाटिनम सरफेस में एमोनिया इज this ammonia is taken over saturated amount, so that any change in the concentration of ammonia will not alter the rate of reaction. Okay, so the gases, which is the absorption of gases on metal surface, are examples of zero order reaction. Okay, now zero order reaction, by using integrated rate law method, how we can determine it is a zero order reaction? By using integrated rate law method, how we will determine it is a zero order reaction? Okay, so let's see. So let us see how we will determine it is a zero order reaction. Okay, so suppose a reaction, let us consider a general reaction A to P, that is A to P. Now at T equal to 0, when the reaction is not started, let the concentration of A is A mole per liter. And what will be the concentration of P? It will be definitely 0, because reaction has not yet started. At T equal to T second, it is seen that X mole per liter of product has been formed. So what will be the concentration of A? It is A minus X mole per liter. Okay. Also we can say that let us consider this reaction. This is one form in which we can express this equation. Let us take another form, that is, suppose we have A to P, then minus D concentration of A by dt is equal to K into A to the power naught. Because how I have written? Because differential rate equation for this reaction is R equal to minus dA by dt, and rate equation for this reaction is R equal to K into A to the power 0. So A equal to B and A equal to C. So you can write this B equal to C. Okay. So that's why I have written. So from this idea we have written minus dA by dt is equal to K A naught, which is equal to K. Okay. Which is equal to K. Now that is you can write, which implies you can write minus dA is equal to K dt. Now if we integrate both sides, because this is an integrated rate law method, so we will integrate both sides. So what will happen if we integrate both sides? So integrating both sides, we will get what we will get, that is इंटीग्रेशन ऑफ माइनस, हम ये इसको बाहर लेके आ गया, dA इज इक्वल टू K कांस्टेंट, इसको बाहर लेके आ जाते K इंटीग्रेशन ऑफ dt प्लस C, where C is called constant of integration, where C is constant of integration, ठीक है. So now this integration of dx is equal to x. This is a mathematics we are going to use over here. So integration of dx is equal to x, so that is why you can write minus a is equal to k t plus c. So this equation thing, minus a is equal to k t plus c. Okay. So now this equation you can give one equation 1. Okay. Minus a is equal to k t plus c. Okay. Now this minus a is equal to kt plus a. Now when t equal to 0, when t equal to 0, a becomes a is equal to a naught. A is equal to a naught. When t equal to 0, a is equal to a naught. So from this, so putting this value in this equation, so putting this value in equation 1, putting this value in equation 1, what we will get? So what we will get if we put this value that is t equal to 0 and a equal to a naught. So what we will get? Minus a naught is equal to c, means the value of c came out to be c. Now putting the value of c in equation 1, putting the value of c in equation 1, what we will get? Minus a is equal to kt plus, it is minus a naught, which implies we can write a naught minus a is equal to kt, which implies we can write k is equal to a naught minus a by t. K is equal to a naught minus a by t. This is called integrated rate equation for zero order reaction. This is called integrated rate equation, that is k is equal to a naught minus a by t. This is called integrated rate equation for zero order reaction. This is called integrated rate equation for zero order reaction. Okay. Now see, let's go to equation 1. Okay, let's go to equation 1. So before going to equation 1, we can write a naught minus a, that is we have a naught. So let's go to equation 1 first. So what is our equation 1? Equation 1 is, just now I have roughed it, equation 1. So what was our equation 1? Equation 1 क्या था? Minus a is equal to kt minus a is equal to kt minus a naught. This was our equation 1. I think so. This is our equation 1. Minus a is equal to kt, a is equal to kt. और इक्वेशन 1 क्या था? इक्वेशन 1 था a is 1, that is c equal to, we got equation 1 was that is minus a is equal to kt plus kt minus a naught. So minus a is equal to kt minus a naught. Okay, so we can write it as a is equal to, which implies we can write a is equal to, what we can write? A is equal to a naught minus kt. A naught minus kt. Can we write? A is equal to a naught minus kt. So is it possible for us to write? Yes, it is possible for us to write. And you can see that this equation represents the equation of straight line. So see, this is our y, this is our mx, this is our mx, and this is our c. So this equation represents equation of straight line. This equation represents equation of straight line. So what we know, what we can plot? So if we plot y versus x, that is, if we are going to plot y versus x, what we will get? So what is our y? Y is a, and x is what? X is equal to t, and our slope, that is m, is equal to minus a. So y यहाँ पे क्या है? Y है a, ठीक है। x क्या है, x है t, ओके। m क्या है, m है माइनस k, and c is a0, and c is a0. So if we plot this y that is log a versus x क्या है t, x क्या है t. So what will be the type of graph? Graph will be like this, with slope is equal to minus k, with slope is equal to minus k. This is a very very important graph, my dear students. This graph is a very very important graph, okay. So please keep it in mind, this graph is a very very important graph. And so this unit of rate constant for zero order reaction is that is k is equal to mole per liter per second, okay. k is equal to mole per liter per second. अभी देखो और एक चीज हमारा in the process of our determination of this integrated rate equation, we have seen that we have k is equal to a minus a naught by t, a minus a naught by t. So a minus a naught is what? A naught is initial concentration and a is the final concentration. So final concentration minus initial concentration means we can plot. Final concentration was जैसे हमने just थोड़ी देर पहले लिखा था a minus x in terms of a minus x and small a, in terms of small a minus x and small a, we can write this a is equal to a minus x, okay, minus a minus x minus a by t, okay. Now this, from this we can write k is equal to, so a minus a naught by t is equal to a minus a naught by t, sorry, a minus a क्या है फाइनल कॉन्सेंट्रेशन, that is a minus x, और a naught क्या है small a, ठीक है. So a minus a naught by t we can write that is equal to x by t. Now if we plot this k equal to x by t, so what we will get, x equal to kt, that is equation, another equation of straight line y equal to mx. So if we plot x equal to t, x equal to kt, so if we plot x versus t, what will be the type of graph? So the graph will be a straight line passing through origin with slope is equal to plus k. The slope is equal to plus k. Okay. So this is all about our zero order reaction. In so इसको zero order reaction, integrated rate equation of zero order reaction is k equal to a minus a naught by t. K is equal to a minus a naught by t. Okay. So from this we can find also this half-life period of zero order reaction, which we are going to do it in our next class. So up to this I want to conclude here for today. If you face any problem in understanding these derivations, you can ask me over my WhatsApp number. So with this I want to end here. Okay. So my dear students, stay blessed and be sincere in your studies. So with this, thank you very much for your patience hearing. Thank you.